Sometimes it can be helpful to have a function that will give us the arc length of a curve from a given starting point to any other given point on the curve, assuming the curve is continuous. We can do that with this formula. Notice we first need the first derivative, y prime. This will give us 3x to the 1/2 power. And then if we slowly build that formula, we'll get 1 plus 3x to the 1/2 squared. That is 1 plus 9x. And now using the formula, s of x is the integral. We're starting at 1 and going up to x. Then we have the square root of basically what we just found, but we do want to change the variable. We'll change that variable to t. We don't want x to have two different meanings, so we'll make that 1 plus 9t det. Now we can use a u substitution. We'll let u be 1 plus 9t. du is then 9 dt. We'll divide both sides by 9. 1/9 du is dt. Now rewriting s of x, we have the integral of the square root of u, which we can think of as, I like to write it as u to the 1/2 du. Don't forget 1/9 is out front. And our limits of integration have changed. The lower limit was 1. If we plug in 1, we have a new lower bound of 10. And if we plug in x to the top, we get 1 plus 9x. Now integrating 1/9 out front times 2/3 u to the 3/2, and we are evaluating from 10 up to 1 plus 9x. We can now plug in those limits of integration. The fraction out front will be 2 divided by 27. U, using the upper limit, we get 1 plus 9x to the 3/2 minus the lower limit is 10 raised to the 3/2. And now we can rewrite this a little bit. 2 divided by 27 times, we'll copy the first set of parentheses, and then negative 10 raised to the 3/2, we can think of that as minus 10 square root of 10. And we now have a formula for the arc length of that curve when the starting point is 1.